Okay, on this part here, we shall consider our exponential equations. Remember, we had a condition of working with exponential equations in our last class. We talked about this, but now we want to work on more complicated questions, just a little bit complicated questions that we can have, which is very, very important. Okay, remember what I said on our introduction. We shall consider that it's not like we are going to refer that part like we are no longer going to talk about that. No, we are going to have that same part where I said if you are given a to the exponent of m, which is equal to a to the exponent of n, these two can only be equal if the exponents also are the same, because as you can see here, we have the bases that are the same. So it follows that the exponents should be equal also. Let me just indicate what I'm trying to say. This base here and this base here are the same. So I said, once you see that, what does it mean? It means this one and this one, the exponents should be equal. So therefore, m must be equal to n. But because they know that you guys, once you understand this and they give you a question direct, 3 to the exponent of x is equal to 9, you can just change that 3 to the exponent of x is equal to 3 to the exponent of 2. You see that, all right, this one and this one are the same. You're going to equate your exponents to say x is equal to 2. This was our last exercise. This is the types of questions that we talked about. All right, but now, like I said, we shall have a little bit complicated questions that we might have that we need to talk about. Okay, let's consider first question. So for x, we are given 5 times, okay, so that first question, 5 multiplied to 9 to the exponent of x minus 1 is equal to 5, like this, okay? And we want to solve for x. Okay, let's consider that this 5 is multiplying and it has got nothing to do with this part that has got x. So what can we do with this? We can simply divide by 5. So here we can simply divide by 5 both sides of this one and this one will cancel. Once this cancels out, what does it mean? Here we are going to remain with 9 to the exponent of x minus 1, which is equal to this one, and this one divides again, we get a 1. All right. If you still remember from our introduction, I talked about the number referred to as 1. This one here is a special number, as it can be written as any number to the exponent of 0, all right? A to the exponent of a 0 is equal to 1. X to the exponent of a 0, as long a number is being raised to the exponent of 0, it gives us a 1. So since we want a condition that we need, remember our condition that we want is to have the same bases here, these ones to be the same. So, and I'm having this as my reference number that I'm going to use because it is the one that is already raising or being raised to a certain exponent. So it means 9 to the exponent of x minus 1 when written in terms of 1. We said it is going to be 1 is any number to the exponent of 0. And here our number that we are referring is the base. So meaning to say here, we shall have it as 9 to the exponent of 0 so that we get a 1, this one. What we want is to have it in terms of what? Of 9, so that we consider our last part that we talked about to say if these two here are the same, the base here and also the base here are the same, what does it mean? It means also the exponents will be equal. Okay, so therefore automatically here x minus 1 must be equal to 0. Okay, once x minus 1 is equal to 0, you are now back to your linear equations. Okay, how do you solve a linear equation? You're going to transpose or take this -1, it jumps the equal sign. Remember that every number that as long it jumps the equal sign, it changes its sign. So meaning to say x is going to be equal to 0 plus 1 and x is equal to 1. Okay, that's 0 plus 1, it's a 1. Remember, any number, once you add 1, means 0 plus any number is that number, okay? So that is how we can solve for these guys. And if you put this value back, like I said, once you are dealing with these questions, you can even test your answers, okay? So remember, our question was like this, so you can even test your answers. This is what you can do to test. Remember, our question was 5 times 9 to the exponent of x minus 1 is equal to 5, okay? So you take this left-hand side, you substitute the value of x so that you test if you get what is on the right-hand side, okay? So let us do that on our calculator. We're just going to substitute direct on our calculator. Remember, we got the value of x here, which is what? Which is 1. So I'm going to substitute 5 multiplied to 9 to the exponent of what? X minus 1. Our x is 1. So it's going to be 1 minus 1 like this. Okay, so we get a 5, which is the same as this number that is on the right-hand side. So that means this x value is true. So this is how you can prove. You must make sure that whatever that you have on the left-hand side must be equal to what you have on the right-hand side. Okay, so that was the same situation as the second question that we have, except that here. Okay, anyways, let us see our question by answering it. We are given the second question, that is 7 multiplied to 49 to the exponent of x plus 2, which is equal to 49, okay? So still we have the same situation. If we check properly here, we can see that there is a number that is multiplying, okay? There's a number that is multiplying here, okay? The 7, which is multiplying. So what are we going to do with this one? We are going to divide by that 7. So you're going to divide by 7, going to divide by 7 here. So this cancels. So you're going to have 49 to the exponent of what? Of x plus 2, which is equal to, if you divide 49 by 7, that's a 7. You can also do that on your calculator. Like I said, your calculator is the only best friend in exam that you can trust, okay? So divide by a 7 here, you're going to get a 7. So this is a 7 on this side. So we are going to check to say, can we write these in the same number? Are we going to have this in the same best, which is the best, which is the smallest, and the one that is in simplest form, and the one in simplest form is this 7, okay? So can we write this 49 as in best of 7, okay? Is it possible? 7 to the exponent of 1, it's a 7. To the exponent of 2, it's a 49. So we can write this 49 as 7 to the exponent of a 2. We can even do that on our calculator to test which number are we going to use as we are trying 7 to the exponent until we get the one that gives us what? A 49. So what am I trying to say? In place of this 49 that we are seeing here, in place of this number, we are going to write it in terms of a 7, the one that we are seeing on the other side, okay? So that is going to be 7 to the exponent of 2 for 49. But already there's an exponent that we are given here, which is x plus 2. And this must be equal to, already it's a 7, but it's 7 to the exponent of what? Remember, if the number is not given here, the number is not given, it means there's an exponent of 1. Okay, so that is the situation, guys. Once you are at this stage, do not forget this one, as long it is equal to this one, as long it is the same, the best and the best, as long they are the same, just like this part. What does it mean? It means these two will be equal, the exponents. You equate the exponents from there. So therefore, it means the exponent here, as it is of 2 into x plus 2 like this, it must be equal to 1, which is the exponent on that side. So you are now done with your exponents. This is no longer about exponents. It's about a linear equation now. Given brackets, how do you solve this equation? You have to expand your brackets. So here you have to expand the brackets. So how do I expand the brackets? I have to multiply everything by 2. So that's 2 times x here, which is 2x. 2 times 2 here, which is a 4. And this is equal to 1. So I can be able to solve for x. If I transpose this 4 to the other side there, it becomes a negative. So that means I'm going to have 2x is equal to 1 minus 4, okay? And that's a minus 3. Or you can just use your calculator. Like I said, that's 1 minus 4, okay? Which is a negative 3. 4 on that side is a negative. So it's going to be negative 3 divide by 2 here, divide by 2 there. So x is going to be what? -3/2. Okay, so this is going to be the value of x, which satisfies our equation. But like I said, we can prove to see if this is true. Okay, let us just try to prove, because we are given that, oh, the question was here. Okay, the question was here. 7 into this, it must give us a 49 here. So we want to prove that this whole part that we had before, this one previously, is going to give us a 49. So let us substitute. Remember, our x, we got what? Our x, we got -3/2. So you're going to substitute -3/2 here. Let's prove. Okay, let us prove 7 multiplied to 49. That's 49 to the exponent of x. Remember, our x, we said, is -3/2. Okay, so you're going to substitute -3/2 there. -3/2, -3/2 like this. Okay, plus 2 like that on the exponent. Okay, we get a 49, which is the same as this 49 that we see there. So it means our x is very, very, very correct. That is how you can actually prove if you are alone and you're working out these questions. Substitute them back, put them back on your calculator. Okay, then you see if the left-hand side is equal to the right-hand side. But if you see that your left-hand side is not equal to the right-hand side, that means the question or whatever that you're doing there is wrong. Okay, number 3, we're given a sort of a fraction there. Okay, that's a fraction. Let us see what you're supposed to do there. 1/49 to the exponent of x is equal to 343. So this is what you're supposed to solve in this case. There we've got a fraction, which is fine. Okay, it's actually fine to have a fraction, but how can we solve that fraction that we're given? Because here we do not have a fraction. Okay, remember, to the exponent, or we are now back to the laws. Before we solve, we need to go back to our laws of exponents. Remember, the moment we see we have x to the exponent of -n, it is written as 1/x to the exponent of n. Okay, so meaning to say, what made us to write this number here to the exponent of x being a positive and with 1/, like this? It means it was being raised to the exponent of a negative. What was being raised to the exponent of a negative? The number being raised to the exponent of a -x. So it means before it was 49 to the exponent of -x, which was equal to 343. All right, so the question is, can we write these two numbers in the same base and getting the same number that we have here? Which base are you going to use? 49, because you are used to 49, at least maybe most of us, we might not be used to 343, but 49, we are used to this. We know that 49 is taken from what? From 7. It is related to 7. And we even know that 49 is 7 squared. But if you do not know that, but you know that somehow it's related to 7, go back to your calculator, prove with your calculator, all right? 7 to the exponent of 2. What do I get? 7 to the exponent of 2, that's 49. So meaning to say, wherever I see this 49 here, I see 7 to the exponent of a 2. So that means I can write it in simplest form as 7 to the exponent of a 2, but being raised to the exponent of a -x, which is already given this one. So there's now an exponent and an exponent, and you know what to do there. Okay, anyways, let us move on to 343. As we have, now that we have got the smallest number that we can have, which is 7, which is the smallest number that we can use, like the prime number that we can choose. So we just have to try on our calculator. Okay, let's move on. 7 to the exponent of 3, it's a trial and error. We see 7 to the exponent of 3 is 343, which is exactly the number that we want here. So it means that 343, this one, is same as 7 to the exponent of 3. 7 to the exponent of 3, it gives you 343. So in place of this, we are going to write 7 to the exponent of 3. Guys, once you are at this stage, you are done. because what you need is to have these bases 7 and 7 to be the same. And if they are the same, what do? I equate the exponents together, okay? So I'm going to equate these 2 times minus x to what? To 3, okay? So it's an equation that I have formed there. 2 into minus x means I'm going to multiply 2 times minus x. We are multiplying there, 2 times minus x. So 2 times minus x, what do you get from there? That's a negative 2x. Negative 2x is equal to 3. Divide by negative 2, divide by negative 2 both sides. So this can be a positive. You are going to get a negative 3 over 2. Okay, remember the negative, you write it on top, or you can write it as negative 3 over 2, the negative in line with the division, or you can just write it on top, negative 3 over 2, like that. Okay, still one and the same thing. So this is how we're supposed to solve for x. So as you can see, we have now the value of x, which is minus 3 over 2, minus, it can be minus 1.5, whatever way that you want, write it, or minus 1,5. We can even test, like I said, we're going to test here. We're going to take our left-hand side. If we substitute our value of x here, we must get this number here. Okay, let us substitute and try. This is going to be a trial. This is a proof. It's not a trial and error. Now we are proving. Okay, so we're going to put our calculator here. So that's 1 over here, 1 over 49. Okay, so that's 1 over this 49 here, 49 to the exponent of x. So it's to the exponent of x. What is our x? Let us go back here. Our x, remember, is negative 3 over 2. So you're going to substitute x, which is negative 3 over 2, like this. Okay, so you substitute properly everything, you get your value 343, which is the same answer, 343. So this means the value of x that we get here is fine, because it gives us exactly what we have on the right hand side, which is 343 for this x that we got. So this is how you prove. Like I said before, you can actually prove your answers in that manner. So you're going to work out all these questions, try as much as you can. You see that it's one and the same thing that you're going to have throughout here. All right, let's see question number 4. What are they trying to say here? 5 multiplied to 125 to the exponent of x plus 3 must be equal to 1 over 125. We still have the same thing. You're going to see it's going to be a different scenario with this one. I'm going to explain that type of a question. But for now, let's see this one. All right, number 4, 5 times 125 to the exponent of x plus 3 is equal to 1 over 125. Never be tempted to multiply these two, 5 and 125. Okay, never be tempted to do that. So what can I do? Okay, before I think of rewriting these numbers in simplest form, let me just get rid of this 5. It's just a number that is what? Multiplying. Let me just divide by this number both sides. Okay, so I'm just going to divide by this so that I remain with this one. Okay, then we can simplify from there. So that's, let's divide. So you're going to remain with 125 to the exponent of x plus 3, which is equal. So I'm going to take this, divide by 5, because I want to remove this. I'm going to divide by 5 both sides here. I'm just going to divide by 5, divide by 5 here. So that means this is a single part here, a single thing. Okay, so what does it mean? Let us see on our calculator here. Just going to divide straightforward and see what's it going to have here. Okay, so that's 1 over 25. I'm just going to open a bracket like that, or just plug in your values, 1 over a 25 like this, over a 5. Okay, over a 5 like this. So this will be 1 over 125. So this is 1 over 125. Okay, so considering that, because guys, you know this, let us not run away from the actual sense of the question or the actual meaning of our calculations into something that we want to work with. Be very careful when you simplify each and every stage and analyze your stages. Okay, at this stage, at this level, or at this stage that we are now, I want you to see something. It's true that we are supposed to write this in simplest form in the base of 5. We also write this in simplest form in the base of 5. But I want you also to see that this is 125, which is the same as the 125 that we have there. So instead of you writing them again, changing them again to another base, which is actually fine, instead, use them as they are. What am I trying to say? Just change this as it is. It's going to just remain as it is. 125 to the exponent of x plus 3 must be equal. Remember, I talked about 1 over. That it means is that number to the exponent of a negative 1. So what it means here, instead of me changing this, going to the base of 5, changing this to the base of 5, guys, I can see that these two, they are the same here. 125, this is the situation that I was always looking for. So if that situation happens, whether it is in the simplest form or not, whether they are fractions, whether they are decimals, as long this situation occurs, I take advantage of it because I know for each and every situation like this, where the bases are the same, it is an automatic thing that the exponents will be equal. So therefore, we're going to see that, all right, therefore, we're going to see that x plus 3 will be equal to minus 1. That's an equation that we need to solve. So x is going to be equal to what? Minus 3 transposed to that side, take it to that side, it jumps the equal sign, okay? So it's going to jump the equal sign, it gets there as a negative. So it will be minus 1, minus 3. So our x is going to be a negative 4. Minus 1, minus 3, that's a negative 4 in that case. So this is the value of x that you're going to have. And like I said, you can prove also with the value of x, it substitute back into your equation, you see that you've got one and the same thing. So this is how we could have calculated this. Like I said, we could have also changed this to the base of 5 if you want to work with the simplest numbers, but take advantage of saying that as long the bases are the same, as long these two numbers are the same, equate your exponents, solve the linear equation or whatever type of equation that you're going to have at the end. Maybe you are formulating a quadratic equation. I don't know the type of equation that you're going to formulate or that you're going to have at the end, but mostly you end up with a linear equation. Sometimes you have brackets where you just need to expand your brackets, collect like terms, and solve. So it depends with the equation that you're going to have at the end, but this is how we can work out this. So like I said, there's a little bit difference that we have, but very simple. It's actually, there's no difference. It's just familiar to this. Only there we had a condition of changing it to be a fraction. If you check what is on number 5 there, there's something that you just need to understand on this question. 2 over 3 to the exponent of x minus 2 is equal to 8 over 27. Okay, if I analyze properly, because the condition, guys, please be careful about what I'm saying. What we just want is to have a condition of this nature. As long these two are the same, whether a and b are whole numbers, we do not care. Whether they are fractions, we do not care. Whether they are decimals, whether they are square roots, we do not care. As long these two are the same, you equate your exponent. That is what you only need to know. Okay? Whether they're decimals, whether they're fractions, whether they are whole numbers, that part does not matter as long they are the same. So you ask yourself, is it possible for me to make this number and this one to be the same? Is it possible? Ask yourself that. Is it possible to make 2 over 3 and 8 over 27 to be written as the same number? And that number is going to be what? Okay, if you work with your factors, you see there's something familiar about 8 and 2. There's also something familiar about 27 and 3. Very, very, very familiar. Okay, what is it? Now let us check. 2 is in simplest form. 3 is also in simplest form. These are prime numbers, okay? 2 is a prime number, remember? 3 is a prime number. So you can test with those ones that are in simplest form. So this is what you do on your calculator. You are going to test with these ones which are in simplest form. So just open your bracket, 2 over 3 like this, because it's already in what? In simplest form, this one. So you test it to the exponent of 2. What do I get? That's 4 over 9, not 8 over 27. So I move on, I get back here. I just have to change this time to what? To 3. Okay, that's 8 over 27. But if you know it by head that 2 to the exponent of 3 is 8, 3 to the exponent of 3 is 27. If you know it by head, there is no need for you to use a calculator like this. Okay, here I'm just showing for all of us to understand. But if you must know it actually by head, you're not supposed even to go back to the calculator like this. Okay, you must just know this one. Okay, so this is what we saw. We saw that we can truly rewrite this as a number which is 2 over 3, but as 2 over 3 to the exponent of what? Of 3. So this one is just going to remain as it is. On the left-hand side, this is x minus 2 is equal to. So we saw that 8 over 27, this one, can be written as 2 over 3 to the exponent of 3. So if you know this, because what you just need to test is that, okay, I have 2. Is 2 to the exponent of what? Which gives us 28. 2 to the exponent of 3, it gives us 8. Here I have 3. Here I have 27. So is 3 to the exponent of what? Which gives us 27. It's to the exponent of 3. So it means 2 being raised to the exponent of 3 gives us 8, same as 3. So these two numbers here, they are just on the same fraction. So you're going to write them as 2 over 3. All of these, they are raised to the exponent of 3. Because 2 was raised to the exponent of 3. Remember this law from our laws of exponents, it states that every number is going to be raised to the exponent of 3. 2 to the exponent of 3 over 3 to the exponent of what? Of 3, which gives us 8 over 27. So you are supposed to know this one by head, yes, but if you do not understand, then go back and use the calculator. We need to move together, so that's why we have the calculator also. So as we can see, we are back to that condition that I was saying, whether it's a fraction here, whether it's a decimal, whether it's a whole number on this one, as long these two are the same, I do not care whether it's a decimal, it's a fraction, it's a whole number, whatever type of number that I'm given there. As long it is the same, it means the exponents also are equal. So therefore here, x minus 2 must be equal to 3 because these bases were equal, were the same. So it's now a linear equation that we are supposed to solve. So how are we going to solve for x transpose? Negative 2 to the other side, it becomes a positive. So that will be 3 plus 2, which is a 5. So that's the value of x there. We are done. So as we can see, it's an interesting question. Very, very interesting type of a question. Yeah, very, very interesting. So you can even substitute the value of 5 here, put it back here, and see if you're going to get 8 over 27. If you are not getting 8 over 27, then that means this value of x is wrong. You have to redo again and until you get the answer that is correct. So it is the same situation that you have on question number 6. They can also have it as a decimal. So as a decimal, you've got two options that you're going to do your question. You can write your decimal as a fraction, which is the easiest way. So you're given 0.25 to the exponent of x being equal to 0.125. It's actually difficult to work with decimals, so I prefer you to work with what? With fractions. So on your calculator, you can just convert. If you know how to convert these decimals, direct 25 is same as 0.25 is same as 25 over 100, which gives us 1 over 4. It's actually fine, guys. It's not a crime to know that one by head. But if you do not know, just simplify 0.25 like this, you get 1 over 4. So this decimal that we see here, as same as 1 over 4, everything raised to the exponent of x, which is equal to, you do the same on the other one, 0, so that's going to be 0.125 like this, which is 1 over 8. So this is 1 over 8 like this. So if we are to check, we are back again to the same situation of a fraction, just like this part and this part. So we have to ask ourselves, just like the last part that we had, is it possible to have these in the same number now? Okay, is it possible to have this 1 over 4 raised to a certain exponent to give us 1 over 8? For this one, you're going to see that it's impossible because this is 8, this is 4. Okay, let's try. Let's try. I want you to see something. This one is going to be impossible. If you try 1 over 4, just open a bracket like this, 1 over a 4 like this, close your bracket, to the exponent of 2, you get 1 over 16, not 1 over 8. If you move on here to the exponent of 3, it's getting bigger and bigger and bigger and bigger and bigger. So what does it mean? It means here I have to work with the simplest number between 4 and 8. And what is the simplest number? The simplest number is 2. So I have to try. Remember, 1 over 4 is same as 1 over 2 to the exponent of 2. 1 to the exponent of 2, it's 1. 2 to the exponent of 2, it's a 4. So if I see 1 over 4 and I see 1 over 2 squared, I still have 1 and the same thing. So I can rewrite this as 1 over 2 to the exponent of what? To the exponent of 2. So this will be to the exponent of 2 times x. This one already here, there was an x there. So you're going to multiply that to x, which will be 2x. 1 over 8, we're going to see that it's 1 over 2 to the exponent of a 3. If you raise 1 over 2 to the exponent of a 3, it's going to give you 1 over 8. Remember, 1 to the exponent of 3, that is 1. 2 to the exponent of 3, which is 8. So it's true, I couldn't write this as a number which was given, the smallest number, which was 1 over 4. I couldn't write this 1 over 8 as a number which is 1 over 4. But I had to choose another one in simplest form, which is 1 over 2. As you can see, they can be written in the same number. They can be written in the same base, which in this case is a fraction, and it's 1 over 2. And whether it's a fraction or it's a decimal, it's a what? I said, do not consider that. What you need to consider are these two the same here. 1 over 2 and 1 over 2 are the same. So what does it mean? A conclusion, it means that the exponents must be equal. So it means, therefore, our 2x must be equal to 3. So how do I find x? I'm going to divide by 2, divide by 2. There I have the exact value of x. So therefore, our x is going to be given as 3 over 2, all right? So you're going to have our x as 3 over 2 or 1.5, or you can have it as 1,5, whatever that you're going to have, but that is how you could have calculated our x. So what I want you guys to do is to work on more questions. There are so many questions that we see on this exercise. I cannot simplify everything, but I want you to try as much questions as you can. They can also be exponents from both sides of the equation, still one and the same thing, okay? If you consider here, we are given on number 12, we are given 0.5 to the exponent of x minus 1, which is equal to 4 to the exponent of negative x. So one and the same thing, you can consider this as 0.5. Remember, it's 1 over 2, okay? That's 1 over 2 if you put it as a fraction. So I'm going to have 1 over 2 to the exponent of x minus 1 equal to 4 to the exponent of minus x. But for this one, it was going to be easier if we take it this way. Say, if I check here, this is 1 over 2, which is a fraction. And this is a 4, which is a whole number, this one. Okay, so what if I just write this to the x, like 2 to the exponent of negative 1, because I know that this is 1 over 2. Because already here I'm having a whole number, so that I avoid having a fraction and a whole number at the same time. I just want to avoid that. Okay, so that I can avoid. So meaning to say, back to our exponents, laws of exponents, 1 over 2 is same as 2 to the exponent of a negative 1. Okay, that's 1 over 2. But what about x minus 1? This one, we are just going to multiply it to the exponent that we already have, x minus 1, like this. Okay, so take note, 1 over 2 by our laws of exponents, x to the exponent of negative n, which is 1 over x to the n. So we are now having a reverse to get it as a negative, okay? So that is the idea there. So in this condition, what about this side? 4, can I write it as a number in base of 2? It's very, very possible. 4 is 2 to the exponent of what? 2 to the exponent of 2. but already there's an exponent which is multiplying there, which is what? Which is minus x. Okay, so at that stage, I'm done. Once I see that the bases here are the same, I see here there's a 2, I see here there's a 2 on the base. What do? I equate my exponents. So what are the exponents that I'm equating here? This exponent to this exponent. So this is minus 1, therefore minus 1 into the bracket of x minus 1 must be equal to 2 into minus x, like this, which is a linear equation, normal equation that you're going to solve. Expand your brackets, collect your like terms, this and that. You're going to be able to solve the equation. Negative times x, that's negative x. Negative times a negative, that's a positive 1. 2 times negative x, which is negative 2x. There's a positive, so 2 and negative 1, that's a negative 2. So you can we're going to collect the x to one side of the equation. This side, it jumps the equal sign, it becomes a positive. 1 jumps the equal sign there, it becomes a negative on that side. Okay, so here we're going to have minus x. Remember, minus 2 jumped here, so it's going to be a positive 2x. Minus 1 jumped the other side, it's going to be a positive 1 jumped, so it's going to be a negative 1 on the other side. So here we're going to add minus 1x plus 2x. Remember, minus 1 plus 2 is what? It's 1. So you're going to have 1x, which is same as what? Which is same as x. So x is going to be equal to what? To minus 1, because here we just have minus 1, which is left on that side. So x was going to be equal to a negative 1. Okay, so as you can see, yeah, this is how your questions might be given as. All you just need is to make sure that you properly work your questions, understand how the question is given, work your questions properly, simplify your questions properly. In whatever that you do, you are supposed to simplify your questions properly. In the simplest form where it is applicable, leave your answer in simplest form. It's very, 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 very important. Okay, so guys, let's revise as much questions as we can. Also revise with your question papers so that you can see how do they ask. Now that you know, you have an introduction, go back and revise your question papers, revise as much as you can. All right, so here, these are some of the questions. Like I said, just try to finish up this exercise. If there is anything that is challenging on these questions that I did not attempt, let me know so that we can work on those questions in our next class.